Okay, chapter 2, we're talking about chemistry and how chemistry relates to life and living things. First thing we're going to talk about are the chemical elements, and we can define a chemical element as the simplest form of matter. Now we need to qualify that a bit and say that this simple form of matter has its own unique chemical and physical properties. So examples of elements would include oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus. If you look at the periodic table of elements, those are elements, and each of those has its own unique chemical and physical properties that differentiates them from every other element out there. Okay? So keep in mind, simplest form of matter that has its own unique chemical and physical properties. Now there are about 20 elements that are required for living organisms, for life. The four major ones being carbon, hydrogen, oxygen, and nitrogen, not necessarily in that order, but Ch2, easy to remember. I'm not concerned you know these percentages, but I do want you to know that these four are the most common elements in a living organism. We also see that there are some lesser elements which make up upwards of 0.006%, and then we have things that are trace elements, which total, all of them together, total less than 0.7% of the entire body. Don't worry about knowing these. I guess the most important one I want you to know are these four here. Now, when we talk about atoms, or excuse me, talk about elements, we have to understand that one instance or one sample of a specific element is called an atom. So for example, we can have atoms of carbon, we can have atoms of oxygen, hydrogen, nitrogen, calcium, potassium, phosphorus, sodium. Okay? One instance of a single element is an atom. And that is the simplest form of an element. What we want to do is we want to talk a little bit about the structure of an atom because it relates to how these different atoms join together and bond together, and we'll talk about that in a little bit. When we look at an atom, what we're going to find is that there are three subatomic particles. And these include protons, neutrons, and electrons. And each of these three subatomic particles, and these are smaller than an atom, okay? These are what make up the atom. Each of these has their own unique properties as well. So what we're seeing here on the screen these are examples of different atoms for specific elements. So here we have carbon, there's nitrogen, sodium, and here's potassium. And what we're going to find is that in the center, in what we call a nucleus, it's not like the nucleus of a cell, but because we have things kind of clustered there and it kind of is the center of the atom, if you will, it's called a nucleus. What we're going to find in that nucleus is we're going to find protons and neutrons. Now these particles have charges, so most of them do anyway. Protons are positively charged. Neutrons are neutral. They have no charge. Electrons are negatively charged. And what we're going to find is that the electrons will rotate around the nucleus of the atom in what we call shells or orbitals. Now, I don't want to get into a whole lot of general inorganic chemistry here because I'm assuming that at some point you'll probably have to take chemistry and you'll get all these. But I do want you to be aware that electrons are found orbiting the nucleus in these shells or these orbitals. Now it's important to note that depending on how many electrons there are in that particular atom is going to determine how many shells there are, how many orbitals. Now what we're going to find is that in the first orbital, or what they're calling here the first energy level, there's only room for 2 electrons. In each subsequent level or orbital, we can have up to 8 electrons. Now there does get to a point where that stops. I believe it's about 22 or 20, about 18 electrons maybe. After you get past this fourth energy level, things get a little bit more confusing. So what we can see here with carbon is that carbon has, in a neutral carbon atom, is going to have 6 protons, and they don't really show those in there, but 6 protons. It's going to have 6 neutrons, and it will also have 6 electrons. Now I say that this is a neutral atom because if protons are positively charged, neutrons are no charge, electrons are negative. If we add up the total positive charges, it gives us a total positive charge of 6. Neutrons would equal 0. Negative charges would be equal to negative 6. If we add up the total charges, we get a net charge of 0. And so a neutral atom will have an equal number of protons and electrons. This will be important later on when we talk about chemical bonding again. Now, how can you tell the number of electrons that a neutral atom would have? Well, what we need to do is look at the atomic number. Okay, so the atomic number of an atom represents the number of protons. Atomic number represents the number of protons. But in a neutral atom, that number can also tell us the number of electrons as well. So if we have something with an atomic number of 6 and we assume it's neutral, it's going to have 6 electrons and 6 protons. Now, one of the things I also want to mention here is sometimes the outer energy level, the outer orbital of an electron, isn't always full, meaning that anything beyond the second level, upwards of the fourth, is going to hold 8 electrons. So the first one is 2, second one is 8, third one is 8, the fourth one is 8. We always call that outer shell the valence shell. Valence. I think I spelled that right. Valence shell. And we call the electrons in that outer shell the valence electrons. Now these are important because what can happen is that what the atoms always want is they want that outer shell to be completely full. And sometimes what we'll find is that it's easier to get rid of maybe a single electron or to add a couple of electrons to that shell from another atom. And that's where chemical bonding comes in.